Alright, so you want to be able to program a computer. You want to have it do what you tell it to do, but how are you going to tell it to do what you want it to do if you don't know its language? Now, computers actually speak a lot of different languages, and in this one we're going to be speaking to the computer using Scheme. Now, deep down, all the languages basically are saying the same thing. Sort of like in German, you'd have like Hund, which means dog, and in English. But they're both talking about the same sort of animal. And likewise in Scheme versus Java versus a bunch of other computer languages, they're all doing the same thing deep down, but it's how you talk to them, at the higher level that makes them much different. Alright, so in Scheme, this is how you do numbers. You just type them in. 53. Now 53.2. And you can do fractions too, like 53 over 8. And it even reduced it for you, which is sort of a nice feature. Okay, now Scheme can do really, really big numbers, like this. Just keep mashing it, yeah? There we go. Now, it can also do negative numbers. Okay. Now, how do you do some arithmetic in Scheme? Let's try plus 50 and 7, like this. Now, doesn't that look a bit funny? Now look up here, this is what you're normally used to. Do 50 plus 7. That's how you do it in a regular arithmetic class. But in Scheme, we prefer to do it like this. You encapsulate it like this. This is called prefix notation because the operator, which is the plus sign, goes before the operands, which are the 50 and 7 here. Like that. Now what about minus? 10 minus 3. We would do like this. Negative 10, 3. Like that, you see? And this gets rid of some of the problems of order of operations. So what if you had 50 plus 7 times 5? That's not particularly clear which one's going to be done first, except that we know that the multiplication goes before the plus. But in Scheme, the order of operation is sort of mandatorily programmed in. So down here, let's say we do plus 50, and then you do this times 7, 5, and then you know that it'll do times 7 and 5 first, and then 50 plus that. It makes it so that in any of your what you're writing down, you know the order of what's going to happen, unlike in regular arithmetic and in many other computer languages where you just have to memorize what's going on. Okay, so let's try just doing a converting an infix notation, regular math arithmetic problem into a Scheme prefix notation. So let's just think of one on the spot here. 3 plus 5 divided by 7 minus 8. Okay, so the 3 plus 5 is pretty easy, just do plus 3, 5. Well, I'll do it up here so it's a bit easier for you to see. Okay, so you just do plus 3, 5, like that. But what about the divided by 7? We can't just put a divide here, can we? We got to put it up here now. Divide that by 7. So you sort of have to think backwards, or forwards. Alright, then minus 8. Put 8 at the end. Now what was 3 plus 5 divided by 7 minus 8? Oh, that's going to be like a that's going to be a number that has fractions in it, so I don't know what it's going to be, but we'll just paste it down here and try it out. Negative 6 and 6/7. Right, that's pretty sloppy. Let's just let's do 14 plus 9 plus 5. That'll give us 14 divided by 7 minus 8. So like 9 plus 5. Okay, there. So that answer should be what? 2 minus 8, so it should be negative 6. We'll see what we got. Yep, that's right. Okay, so that's how you convert between infix and prefix notation and scheme. Now let's go ahead and oh yes, how about some variables, like what about if you want to do pi? You know, you want to check the circumference of something, so you multiply times 2 times pi, 3.14159. Oops, 159. Oops, 159. And then your radius. Let's say your radius is like 7. Okay, and there we go. But let's say we don't want to have to type in pi every time. We can define a variable named pi. Define pi 3.14159. Now whenever we type in pi, we get 3.14159. So we can just do 2 and multiply 2 times pi times the radius, which was 7. There we go, we get the same answer. Now you'll notice here as well that this multiplication argument function can take as many arguments as you'd like. So we can do like times like this, quite a lot of them. And it's the same for plus and divide and minus as well. Alright, well, in the next lesson you're going to learn about lists.